Now we're going to look at the last part of this lesson is solving applied problems involving parabolas. So again, this is from the textbook. Parabolas are used to design many objects we use every day, such as telescopes, suspension bridges, one of my favorite applications, like the Golden Gate Bridge. It's a great example of using parabolas. Microphones and radar equipment. Parabolic mirrors, such as the one used to light the Olympic torch, have a unique reflecting property. When rays of light parallel to the parabola's axis of symmetry are directed towards any surface of the mirror, the light is reflected directly to the focus. This is why the Olympic torch is ignited when it is held at the focus. And this is the property of parabolas. So this goes both directions, by the way. So yes, anything coming in parallel to that axis of symmetry will bounce and go towards that focus. And this is true also with like satellite dishes. And I've seen survival videos where people will take those big 8-foot dishes and they'll put something at the center, at the focus I should say, and it'll heat it up real quickly, but they burn themselves, like they've got second and third degree burns in a quick time. There's also different solar plants that use reflective dishes like that, reflective mirrors. I saw one out in the desert by a place called Kramer Junction in California, and it takes those sun rays, hits it, they put a pipe along in the middle, so you have like a trough that goes along, and then there's a pipe in the middle of that, they're down the focus of that, and it heats that pipe up with oil, which then works to turn turbines. It's a really cool concept. But also with your parabolic dish, you'd have your flashlights, and your headlights on the car would, well, they may be changing now with LEDs, but they'd have the light element here, and it would come down and bounce and give you a directed beam. And so I think some of them have like a little blocker here, so you're not getting light going all these directions, but you get this focused beam of light. A really neat property of parabolas. So parabolic mirrors have the ability to focus the sun's energy to a single point, raising the temperature hundreds of degrees in a matter of seconds. Thus, parabolic mirrors are featured in many low-cost, energy-efficient solar products, such as solar cookers, as I mentioned, solar heaters. I've seen some of those. They're really cool. They're kind of heavy to take backpacking, but if you're doing camping, you can do them, and even travel-sized fire starters. So for example 6, here's the image down here. A cross-section of a design for a travel-sized solar fire starter is shown in the figure. The sun's rays reflect off the parabolic mirror toward an object attached to the igniter. Because the igniter is located at the focus of the parabola, the reflected rays cause the object to burn in just seconds. Find the equation of a parabola that models the fire starter. Assume the vertex of the parabolic mirror is the origin of the coordinate plane. And then use the equation found in part A to find the depth of the fire starter. So we're going to find the depth based off the fact that it's 4.5 inches wide. Okay, and so our focus looks like it's going to be 1.7 inches above where the vertex is. So we could say P equals 1.7. So 4P is going to be equal to 4 times 1.7, which is going to be 6.8. So this could be modeled by x squared equals 6.8y. There's the equation that models it. Now the next question is, what is this depth? So if we cut this in half, we will have 2.25 inches. So what is this point on the curve going to be? So for its depth, well, we know the x is 2.25. We want to find the y. So we could say 2.25 squared equals 6.8y, or y is equal to 2.25 squared divided by 6.8. And that comes out to be approximately 0.74 inches. Okay, and that's it. A lot of fun properties about parabolas. I could probably go on for days about them, but I'm going to cut this one short, and this will finish off this lesson.